Welcome to the Simple Questions podcast. This is your host, Dylan Carnahan. You're listening to Feeling Low by Times and Places. Built on the songs of frontman Noah McNair, this act is a smooth ride across the sonic spectrum of jazz, improv, rock and roll, and rhythm and blues. Covering favorite songs and original music with the same freedom, each musician improvises out of their own mastery and taste to create a one-of-a-kind sound. The question for this episode is, how do ants live? You will learn in this episode the social structure of ant colonies, how ants communicate with each other, and the role of an ant queen. Our guest is a Brazilian PhD student at Stanford University, has researched the biological rhythms of foraging and leaf-cutting activities on colonies of leafcutter ants, and developed a machine learning software to identify and count ants in their ant trail. I introduce to you Mila Pamplona.
Down on my knees just to taste all the words I've been eating. You wouldn't believe it if I told
We're recording and we'll just kind of jump into things. So we're talking all about ants here, and from my perspective, the first kind of exposure I had to ants was as a little kid, just out in the backyard, messing around, looking at ant hills, and then kind of seeing these ants walking around. And then I think my infatuation got to the point where I got an ant farm, and kind of had one of those for a little bit. Probably was knocked over by a dog or something at some point. But that's when I think about ants, like those are kind of my earliest memories. Can you tell us about your background and how you became interested in ants?
Oh, I think that's a very interesting start, like talking about childhood stories, because I think ants is kind of a topic that is, if you study them, everyone in the world can relate to that because everyone has some experience with ants. So like if I
Yeah.
go to a bar or like whatever, when someone asks me, oh, what you do for your life? And I say, oh, I research ants. Every single person has a different story and it's always very exciting. And I think it's really good to engage to people. But my story with ants is kind of like interesting because I did not like ants very much. Like I had a bad experience with them as a kid. My parents, they kind of have like a farm and things like this. And I was playing and I was building like a sand castle. And I didn't realize I was using the sand that I was using was actually an ant nest. So I got beaten a lot, like was bad. And after that, I became like very like I'm gonna get revenge after all these ants. So I started getting like some water and then filling all the holes that I knew were ant nests with water, and I would count like how many seconds until like they are filled, so I would know the size of the ant nest. And it was very interesting to me because sometimes I would like fill them up with water and the water would get out in a different hole
Area.
because like there are different entrances to the nest. And I was like, oh my God, this one is really big. Like, yeah, they will never get me again. So I remember that this was one of my first memories with ants. Like, I think I was like 6, 7 years old. And then, like, I really loved science. I loved animals, but I think I really were into like how things work. I think this was my main question. And I got into biology. Sorry. In University of São Paulo in Brazil, and I was like around my second year, and we had like this neurophysiology class that was super cool. And one of the professors talked about circadian rhythms, and her name is Gisele Yoda, and I fell in love with circadian rhythms. I was like, this is the coolest thing ever because you can bring everything together: physiology, behavior, ecology. And I thought was like evolution, all the coolest topics that biology had. And I wanted to work with her because I was like, oh, that's so cool.
Yeah.
But she knew me because we organized like another project together, like a conference. So she kind of knew me pretty well. And when I emailed her by the end of my third year saying, hey, I want to do my final research project with you. And she was like, hey, come on meet. Like, I didn't know you were so interested in biological rhythms and circadian clocks. And we started talking, and she asked me, like, oh, what do you prefer studying, like vertebrates or invertebrates? And I was like, definitely invertebrates. But she studies like vertebrates. And she started asking like a lot of these questions, like, oh, so what do you like? What's your favorite animal? I was like, oh, I actually love cephalopods, like mollusks and things like this. And she was like, okay, that's a really tricky. And by the end, she was like, Mila, how do you think you could work here? You don't
Yeah.
like mammals, you don't like vertebrates, and you just want to do circadian rhythms. How we're gonna do that? But I was like, I don't know. I just wanted to do something. I'm okay with that. And she started laughing a lot. And she said, the good thing is that I know you really well. So I was expecting that. So I think I found something for you. How do you like ants? And I was like, okay, I think they're cool. Like they're nice. I remember like A Bug's Life and things like this was pretty
Yeah.
cool, like the movies. And she told me, okay, read this. And she gave me like a dissertation of a project in another lab in the same department, the Cognition Sciences lab. And it was about temporal organization, like timing organization in the whole ant colony. And after I read that, like it's kind of complicated, but the main thing is that they developed like a software, a machine learned software to count ants. So it was like a very like new techniques and solving problems, and very like how can I say, forward science. Like they're trying to solve like hard problems in the that lab. And that meant like a lot of work. And then she said, maybe we should do something with this and apply this to chronobiology and circadian rhythms, and then you should get to know the ants, and I'm going to be your co-advisor. And I was like, okay. And like I went to this new lab, and it was really nice, and I fell in love with the ants because I used to study leafcutter ants,
Uh-huh.
and I stayed there for 5 years. So it was like 2 years doing my undergrad research and 3 years doing my master's, all with the same project, like basically trying to see if the whole colony behaved collectively in a rhythm way. Like, can we look at the whole colony as like a super organism, because they need each other to work? So this is the level where where like ants reproduce and this kind of thing. And I did a lot of work on that, and I fell in love with the leafcutter ants. They're very cool, very interesting. They're crazy. They I think their behavior is like, working with like them, it's always a little bit of an adventure. Like I never did field work, but even in the lab, they are like, they always run away, like they find their ways to like get into new places. One time, like I remember that they told me that they ran away to the kitchen in the department, and they were stealing like cake and cookies and things like
Really?
this. Yes, I'm like, oh my god. And we had like to take care of them. It was very funny. Yeah, and I love them because they were like so crazy. I convinced my previous advisor, Professor André Frazão Eleni in Brazil, to name all the ant colonies after pop divas. So after that, I could say that I worked with pop divas. Like, oh, I've been studying Shakira. Like, I've been working with Shakira, Britney Spears, Rihanna, Beyonce, Madonna. So it was very cool. I had a lot of fun with them. Yeah.
So, wow, it's kind of that's a good intersection. You had like this vendetta against ants originally,
I had.
right? And then it kind of aligns with kind of these biology interests that you have, and again, you're figuring things out. That kind of problem solving really resonated with you.
Yeah.
Um, what happens from that point of kind of studying leafcutter ants, and how do you kind of know Dr. Gordon?
Yeah. I think this story is also kind of funny. Like I started working with these leafcutter ants, and every time I was learning more and more about them, I was like, very fascinated, about what they can do, like how big the colonies can be, how smart they are, like how they are
Mm-hmm.
resourceful to solve challenges. And I became really interested in that. And I remember that I think it was one of my first lab meetings, like around the end of 2016 or beginning of 2017. And we used to like read papers from, it was kind of a journal club. And we read a paper about Dr. Gordon, like it was the author, and it was about task allocation. And I never heard about task allocation before. And task allocation, I think it means something that I think is very interesting, because when we think about ants, we think that they all have something to do, and it's something specific, like they need to perform this task. It's super control, everything is
Yeah.
super organized, like discipline, discipline, discipline. And it's not like that, because task allocation shows that according to the needs of the colony, the ants can change what they need to do. So this is what task allocation means. I mean, you can be searching for food, but now, oh, something is attacking the colony. We all need to like fight to defend the colony, and they all stop like looking for food, and they will fight to defend the colony.
So
Or we need to take care of the babies, and they will do that. So I remember that I read this paper, and it was funny because it was me and another undergrad, like new in the lab, and we read the paper and we both loved the paper, and we were like, this is the coolest idea we ever heard about ants. And everybody was like, the older students, like the graduate students and the PI, they were very excited, because we were like, yes, ants, they're the coolest, I love them. And every time that we talked about the paper, we would refer to the author as he, because we have like this idea that science also always comes from men, you know. And this is a society issue. We're trying like to destroy that feeling now. And but we didn't know, like we never read like the whole name of the person, and we were always talking about that. And at some point, like someone corrected us and say, you know that the paper is actually from a woman. Her name is Deborah Gordon. And I remember that my friend and I were like shocked and like a little bit embarrassed, because, oh my God, we're women, we're feminists. And we also assume like this bad thing that it's always like a man that did a great work. Oh my God, how society like destroys our way to see the world. And then my friend, like she was with the paper printed in her handle, and then she hit it on the table, and she was like, that makes the paper even better. Of course it was a woman. And then we both was, yeah, that's so cool. And so like from the beginning, like I really like her because of these papers, and I really love reading her papers. And in 2020, like I decided to apply to the Stanford biology preview program to get into the PhD program here. And after that, like they saw my application, and they said, and one of the reasons that I wanted to apply is it's because they had in the program like faculty meeting. And I was like, okay, even if I don't get in, maybe I can like talk to Deborah Gordon. It's gonna be super cool. And then like they said, oh, okay, we think we should apply here. And in copy of the message, this is the content of the professors that you said that you thought you liked the work. And like 7 minutes after I got that email, I was like, oh my God, Stanford thinks I can apply to Stanford? Are they insane? Like, and then 7 minutes after, Deborah sent an email to me saying, hi Mila, would you like to meet? Let's have a Zoom meeting. And it was to me like, oh my God, I can't believe that's happening. I remember that I was looking to my cell phone,
yeah.
shocked, you know, like I could never expect that. Like I come from a small town in the state of Bahia in Brazil, and then I moved to São Paulo. It was already such a huge thing in my life because I wanted to be a researcher, and it was like a lot, you know, like just moving, going to a bigger university, like a scientific big university in Brazil. And I would never imagine that I could actually meet one of like the
Yeah.
professors that I really admire the work. And she wanted to meet me. She sent me an email saying, hey, let's talk. And we talked, and after that, like she was really nice, and I was very happy, like, oh my God, she's so nice. I did so great. And we and then we started talking, and I decided to apply to the PhD. So I applied in 2020. I got waitlisted first because of the pandemic and a lot of things, and then I applied again, and now I get in. I got in. So I started working with her. So I'm a first year yet. We haven't done a lot, but we've been like talking a lot in the past couple of years. It's been really nice. So yeah.
That's awesome. It's awesome to hear that progression. It's really odd, right? Some of those kind of moments in your life where you kind of reflect, you're like, wow, hey, I was just reading this, now I'm having that conversation with that person, right? It's an odd feeling,
Yeah,
especially when you just kind of reflect on things. But it's
yeah,
happy. It's good to hear kind of your journey, and where you're at and how happy you are with that. I'm going to
yeah.
go back to something you previously mentioned, and you were talking kind of around this idea of, is an ant colony, one organism kind of, and then you talked about task allocation, right? Where kind of these ants are more like generalists rather than specialists, right? If whatever the
Mhm.
situation dictates. Can you talk a little bit about how ants communicate with one another?
Yes. I think like first, I think it's very important to acknowledge that there's a huge diversity in ants. I think there's between like 14,000 to 18,000 species, and they are
Wow.
distributed all over the world. So in so many different environments, and that means that basically they have a lot of diversity, like you can pretty much find an exception to every single rule, that we have. Oh,
Uh-huh.
ants always do that. Oh, but this species doesn't do that exactly
Mm-hmm.
because it lives in that environment and its evolution was different. So I have to say that when I think about all this diversity in ants, what I honestly think is that I know very little about ants because I know more about leafcutter ants and also about like some other types of ants, but I feel like I can always like get surprised and amazed about a new species that does something completely different. So I think that's really important. But something that is really crucial to communication in ants is the smell, like their chemical compounds that they have in the hydrocarbons, like they have in their bodies, and this kind of have like an identity to each
Okay.
ant and also to each colony. So what they do to know if something is from the colony or it's not from the colony, they go close to each other and they use the antennae to smell each other. So they touch like it's very cute. I love that when they do that, and they smell each other. They can tell, okay, you are from my colony, so you're my sister, or no, you have a similar compound, like you are from the same species, but you're not from my colony. So
Mm-hmm.
I need to pay attention to you because you might like invade my colony or something like this. They're very protective with the colony, and they can also recognize all different things. For example, if an ant is sick, they smell this ant and they can tell it's sick, like it's contaminated with something, and usually like they will find a way to protect the colony from the sickness. So they do like a self isolation or like to separate this ant, so to protect the colonies, like they do a quarantine. It's pretty cool. Like I read a paper like this in the time we had like COVID, like really big, like 2020, 2021. And I remember that I was like, oh my God, I know so many people that cannot quarantine right at like the right way. And the ants are better at this. And they still keep saying that we are smarter than ants. Like, what is this?
That's
Yeah.
that's really interesting. I guess to continue along with that scenario of kind of that communication and ability to discern whether something, is from their colony or not. What would happen, if an ant detects something that's not from their colony, that's a predator? And I guess what are predators to ants?
Yeah. I think there are lots of things that can happen also because of like the diversity that ants have. But some species they are like very aggressive. So what happens is that they can release, for example, leafcutter ants, they do that. So they release like a pheromone, like that's like an alarm, we call it, like, because saying that they are in danger, like something like this. And when they do that, the other ants can smell that, and they are recruited to protect the colony. So they all start attacking this different thing. Like one time in our lab, I remember that a spider got into like one of the ant nests, and I was very like, oh my god, like this spider's gonna kill the ants, super. And I was like,
Yeah.
was one of my first years, I was very like, oh my god. And I was like, I will have to take the spider off. And I had arachnophobia. Now I'm trying to so I was very scared at the moment. And everyone's like, I was like, someone please come help the ants because the spider is there. And they didn't like, when I came back, like, to people said, oh, go back, you're gonna see what happened. And the colony was attacking the spider, and they were like taking their legs off. And I was like, oh my god, they really can manage, like, can take care of themselves. I was
Yeah.
like, of course they can. I mean, like, they have evolved, like, but I think that can happen a lot. There's a lot of conflicts and within the colony, because they're facing all these challenges. Like, they have to fight with their neighbors for resources, they have to protect themselves for predators. So I think there's a lot of things that can be involved in that. uh, One thing that I like, it's something that I really like watching. There's this video on YouTube that's called Ant World War, or like World War Ants, something like this.
Okay.
And it's an animation, and it's pretty cool. Like, they show exactly this, like how they interact, how they perceive information, how they protect the colony, and how they can fight within like different ant species. Like, there are some ants that when they found something, like they're very aggressive again. For example, if they fight with a different ant, they will take like the heads of the other ant and place it in the entrance of the nest. So it's like a message. you know I think that's so funny, honestly, like. But they do that. It's like there's a lot of specific behaviors, like how they deal with things that are different, they're not from the colony. And I think that's pretty cool. Like, there's a lot of diversity, very nice.
That's that's crazy. It's
Yeah.
almost like you go back to like some Game of Thrones or medieval movie with like a head on a pike, like, hey, look,
Yes.
not welcome here. That's crazy. I know we've alluded to it a couple times about how there's just so many ant species, and that brings up like again, like, well, there's some exceptions. Like you said, everything kind of can be covered by one species or another. What are some of those, I guess, common ant species that we go back to kind of those childhood stories that we would be interacting with?
Mm. Uh, I think that depends a lot on where you live. Like, I think for most people that live in urban areas, they have like their interactions a lot with Argentine ants, because they are invasive. So here, for example, in the US, like, they're everywhere. So like, they're actually like a problem in some places. Like, I remember from my experience, I like growing up in Brazil, and I grew up in the Brazilian savannah, Cerrado, it's our name for it. I remember a lot of like, now I know that they are like leafcutter ants. I don't know like a lot of the other ones. Like, I was pretty bad at identifying ants. I'm still learning that. But I think there's like leafcutter ants are really like big on Brazil, for example. Uh, but there are so many ants. Like, it's insane. I feel like, yeah, it depends a lot on when you are here. I know there, for example, near the Stanford campus, I know there are leafcutter ants, winter ants, harvester ants, and I think around here in California, people can find a lot of them, and there are different species too. Yeah, but it's a lot. There's a big diversity. And something funny, for example, about the Argentine ants is that uh, when they are very present in a place, they came from like the north of Argentina, and they're all over the world, and they are really successful to when they live in urban areas. So, for example, there's some. I remember that I went to an ant survey here that it occurs on Jasper Ridge to monitor like the diversity of ants there.
Okay.
Basically, that's what we do, and we find most of the Argentine ants in the like in the border of the reserve of Jasper Ridge because it's kind of closer to urban areas. And when we find Argentine ants, we don't see a lot of diversity. We only find Argentine ants. Sometimes we can find winter ants, but when we go like to the places like they're kind of more in the center of the reserve, we have a whole new diversity of ants. So we can find all of them living together. So this is one of the reasons that they can be a problem because they are kind of aggressive and they it's like the other ant species avoid being near them, you know, because it's gonna be a problem. There's even some work that thinks that like the Argentinians are kind of a super colony because usually, as I told you, like because they can smell each other, they know when they are from the same colony. And
Mm-hmm.
even when it's different species, they can the same species, they can recognize that it's from a
Yes.
different colony. So they can attack each other. Like I have seen like leafcutter ants attack leafcutter ants. But from the same species, like Atta sextans, that was the one that I studied in the past. But Argentinians they kind of don't do that. They do not attack each other, even when apparently they are from like different colonies. And people are trying to understand what exactly that means. Some people even think that it's related to their diets, because according to what they eat, not only like the ants but other animals too, it changed the way like they have the hydrocarbons, so the substance that they have in their bodies. So if you recognize each other by the smell, according to what you eat, you're gonna have kind of the same smell. So maybe because they live in urban areas, they kind of have access to the same resources, so they maybe smell the same, but maybe it's something different, like some like their genes are different, or like the way
Yeah.
they smell is different. Like we don't know, or people are still trying to figure that out.
That's really interesting. So I guess the one of the potential root causes for their ability to kind of spread is the fact that they're more unified than other species, being that they don't discern between each colony and therefore have some infighting. So that
Yeah.
enables them to kind of reproduce and spread more. Um, as far as them, that Argentine, is that correct?
Hmm.
Argentine?
Yes.
That ant species being invasive, you mentioned to kind of like North America. Um, how does that occur? How do we have ants from Argentina, I would presume, in the United States,
Yeah.
for instance?
Yeah, I feel like I know that I'm not sure if people have like a specific like explanation for that, but apparently they came to the US in like the beginning of the 20th century, so like kind of 120 years ago, and they spread really really quickly. But that happened to a lot of places in the world kind of in the same time. So I think, as many other invasive species, that's something that came with globalization, like because we became so much more connected that sometimes something's there and that something spreads. Some people, like in some cases, some people like bring things from different countries to another. They're like, oh, it's okay, and then they're like, no, I cannot handle that, and start spreading. So I think the story, like what happened in the say when you think about the process, is probably the same, like the connections between the countries. But I don't think they know exactly what happened, because that's it. It's kind of hard to know when they spread so fast. And uh, also, like, to know exactly what happened, it means that we have to have very specific data monitoring the species. You know, like someone needs to like know always. For example, if we would say, oh, they actually spread over like the in a specific area. So like they came all over South America, they were coming up and up and up. We would have like to have people monitoring this data all the time to see that the diversity was changing, and they sometime arrived on the North America. But we don't have, I think, this kind of data, and it's more likely that was through like globalization and like ships and things like
Yeah, you
this.
have that's a great point. There's a couple of things that are to digest. The first thing is if this is 100 plus years ago, it's really hard to discern maybe the genesis of what
Yeah.
brought that over. But as you've pointed out, trade is a big thing, right? An ever increasing globalized economy, goods come over. And I know that's something that even, countries do inspect, produce and things like that come over from different countries. And that certainly could be a means to bring in invasive species. As
Mm.
far as this specific species or other, invasive ant species, is that something that I guess how do we solve that problem that we have these ants over here and there's either, potentially killing or warding off other species and hurting biodiversity? How do you tackle that problem?
Yeah. I have to say that is probably one of the hardest questions for biologists and ecologists. This is something that, because invasive species are problems like everywhere. I remember where in Brazil, like in the sea, we have like this specific coral that was getting everywhere. And like, I know it's impossible to take him off because when you try to take it off, he reproduces. And like, you have to have a specific training and you cannot like throw something in the middle of the ocean because it's going to disturb the whole environment. So taking care of invasive species, it's super hard. I don't think we have a solution for that. What we can usually do is like something to mitigate that. So if you know we have enough information to know, okay, where are these ants? How do they behave? What they do now? How are they spreading? We can do specific, find specific solutions to the problem. I would say, for example, for Argentine ants, thinking about like in your home, one thing that people like, some people recommend is like to like don't keep food like on like don't let the trash because that attracts the ants. Also they really love like places that have they're humid, like they have more water. So this is actually one of the reasons they get in so much into the houses, because they want food and water. And I saw like a website the other day saying that you should like, if you have wood you need to in your yard, you should keep the wood far from the house entrance because that kind of attracts leafcutter ants. But I don't know exactly why they say that, because I don't know if there's a specific type of food or it's a general type of food that does that. That's something that I haven't learned yet. I know that, for example, what I learned around here, that you usually can find Argentinians near urban areas and on oaks. So I remember that people were trying, I was trying to learn how to recognize an oak because we don't have oaks in Brazil. And I'm terrible, like I'm a terrible botanist, like terrible. I just like passed the classes and I'm like, okay, Mila, you want to be a researcher in ecology, you need to learn a little bit more about other species that the ants interact with if you want to study ants. And but that what I remember. But yeah, it's very hard, I have to say. It's very hard. Like myself, I have used like this ant traps in my house once. I don't like that. I always try to do other things like to take them off, but there are cases that you can't do anything. Like I remember, for example, I have a friend of mine and she called me because in her work, like the building, they found out that there was like a wood part, like, and they realized there was an ant nest over there and it was all over the wood. And she was
Mhm.
like, we want to like take them off. And I was like, okay, there's some things that you can try to do, but if the nest is all over the wood, there's nothing you can do. Like
It's
you will
theirs
have like to
now.
destroy the, yeah, like it's, yeah, it's gonna destroy it. Like there are some species that they're really good to get into like electronic stuff, and they live there and they destroy the whole electronics. That happens a lot in Brazil. I don't know if that species is here and I cannot remember the name exactly, I'm sorry for that. But I know that they do that a lot, and it's a real problem there, because if they, after they finish like destroying this place, if you try to
Mhm.
take it off, they will move to a different electronic or like machine in your house, and they're gonna destroy it again. I
Wow.
remember that I had a professor that studied bees in Brazil, and we were organizing like this conference for social insects. And she was like, Mila, I'll take you to my house to solve my ants because they were there. You know, they destroyed my printer, and now I think they are on my fridge. I don't know what to do. I'm gonna take you there. I'm like, I don't know what to do either. I think this is really hard. You know, it's a really hard thing to do. Like, I'm sorry, but I don't know. Maybe I don't
Get
know.
some
Maybe
oak
like
maybe in the backyard away from get
yeah,
something,
and
throw
it
a
all like it also depends. Like for plants it's a little bit easier. You can try plants or like some food that you're like dog food, for example. There's some things that you can do. I remember that we used to use some cotton to put like near the plant, and a little moisture, like little water on this. And then, for example, a lot of ants, when they climb, they get stuck to the cotton. So because like the trail like kind of stops, or it's not like super reinforced because they get stuck, that means that they're not going to forage so much over there. So there's not going to be a lot of ants there. So I'm going to go back to explain why that happens, because ants, they don't know what they're doing. Like it's not like, okay, I know that there's food over there. When they are foraging, they're looking for new food resources. And what happens when like they find food, usually they come back and they recruit the other ants to go there, explore that resource. So it's like they go there and they say, hey, oh my god, it's such a good place to eat. And they come back and they say, hey girls, let's go get everything. And they come and they go there and they get this new resource. And because these ants went there and got the resource, when they come back, they can, for example, that happens for leafcutter ants, they mark the trail when they come back. And then all the other ants, they have like this clue of like this chemical compound saying, if you go that way, like following this chemical smell, this trail, you're gonna find a resource, a food resource. And then they go,
wow.
they get there, they get this new resource, they come back also like marking that trail. And then that trail starts to like smell really, like has a really strong smell, like that chemical compound is over all over. And a lot of ants start being recruited to that trail. That's why, like, if you look for videos, like especially like leafcutter ants, I think they have a lot of documentaries and like videos showing that's very pretty foraging trails, like they're all going like carrying their little leaves or
Uh-huh.
something's very cute. And why are they so organized? Like, why are they in this specific area? Because ants are always marking that part, and they know, okay, that's the way that we need to go. Like, if you still like take them off, like there's gonna be some kind of disturbance. But they kind of like the pattern of foraging arises of like the collective behavior. You know, like that's what's cool about ants. Like they are doing things together because they recruit others, and the others go there. That doesn't mean that it is super effective, because I mean, sometimes you can find a, imagine like the situation, you find a resource, you go there, you ask your friends to come with you, you go back to the resource is not there. So
Yeah.
sometimes like the way that they organize trails doesn't mean that they have like the best resource for food or something like this. They're trying to figure out. And that's actually something that I think it's really, really interesting about behavior in ants, because they don't do exactly the same thing. Apparently, like colonies, they change the way like they organize this kind of thing according to like the size of the colony, according to where they are. If they, for example, it's a colony that is younger or an older colony. So a lot of little things like can affect that. That also, these processes can be affected by seasonal things, like seasonal changes. So it's a lot of things. It's very complex, I have to say. Like, I feel like when people go to that way in the research, and this is something that I love it, I think I might go there. It's really hard to know the answer, because the answer usually it depends. When that happens, usually that happens. But when that also the other thing happens, then it's a completely different thing. So that shows that the colonies, they are organized, they have this collective organization. And but it's an auto, like it's a self organization. And it's a process that arises. It's not something super coordinated, super controlled, but it's also super dynamic because ants are always like having this process of like going somewhere, seeing what they find, coming back, uh, communicating this to other ants. Some ants are recruited, sometimes they're not because they go to a different place. We don't know exactly what happens there. Like, why did not follow that ant and they went to the other way? Was the trail, was something else? We don't know. It's just a lot of questions to ask and to
Yeah,
answer.
that's a there's a lot of different things there, and I know that you kind of talked about that adaptability and kind of, again, we've been talking quite a bit about kind of communication. Let's kind of delve into what is the social structure of an ant colony.
Yeah, I this is also, I think it's we have like this classic structure that is the same like kind of all the social insects, because all of them, they have like this division of labor, and it's really important to characterize that it's also like a division of reproductive labor. So what usually in colonies and other colonies of social insects like bees, wasps, and termites have is that they have a specific group of individuals that can reproduce, and they are the ones that reproduce in the colony. And we have a whole group that's usually much bigger that cannot reproduce, that is infertile. And this group is responsible for doing all the other things that the colony needs. So they need to take care of the brood, they need to look for food resources, look for water, protect the colony. And this is kind of the basic structure. So what we have, the ones that reproduce, usually it's the famous ant queen. She's not
Hmm.
taking care of everything. It's like she's the reproductive system of the colony. If we think as a colony as a organism, so
Hmm.
she's reproducing, and that's her job. As humans, we think, oh, she controls everything, but she doesn't. She's kind of reproductive system of the colony. If we look to a colony as we think about a whole organism, and usually we measure the age of each colony as the age of the queen. So if the queen dies, the colony dies.
Really?
And that's their job. They're reproducing, like laying eggs all over her life. And she never stops. It's insane. It's like, oh my God, it's a lot of work. We should actually be sorry for the ant queens because it seems very stressful. And all the other ants, or like the other individuals in the colony, they're gonna do all the other tasks. And one thing that's really cool in different ant species is that we have this major structure, but we also can have like this division of labor in a way that you can have a specific task, and you also have a different morphotype, like your morphology is different, so you can perform that task better. You can also like all be the same and still like do different things, but the main thing is that the colony is dynamic. So even if you have a preferential task, you're gonna do what the colony tells you to do, like what you are recruited for. So for example, if someone looks for leafcutter ants, you're gonna see that they're very different because they have like these patrollers, like, or soldiers, and they're really big. They have like these huge mandibles, like looks like amazing scissors to cut everything and to protect the colony. The foragers, they usually have like again like a mandible that is really good for cutting leaves. And we have like these tiny ones that are the nurses that take care of the brood. They don't have such a big mandible, so they're not really capable of cutting stuff. But at the same time, like according to the need of the colony, everything's very flexible, say, so they can be recruited to do different things. In my work, one of the things that I measured, it was the leaf cutting activity throughout the day. And usually like the foragers, like they're the ones that have an intermediate size, they're the ones that are looking for food all the time. But you also see a lot of soldiers in this, like the ant trail too. And a lot of times they were like carrying leaves, and they were not like actively protecting the colony. Like they were just going all over patrolling. you know, these patrollers, but they were actually leaf cutting too, carrying leaves and bringing them back to the colony. So a lot of things can happen. So it's very dynamic. But as I also told you that we have so many differences in the ant colony, like to this structure, there are some species that they have the ant queen, but they have also a group of workers that they, if the ant, something happens to the ant queen, for example, it dies, these workers can become reproductive, like, and then they start laying eggs, but they do not like become a queen because they're actually workers. So like the reproductive system and then like becomes activated, and they start laying eggs, and because of this, like the colony can live a little longer.
Mm-hmm.
So and people, so this is interesting because some people are trying to understand this kind of thing related to longevity, like aging and things like this. Because if you look for like the workers, they will live like a year, and then when they become reproductive, they start living 5 years. And usually like the ant queen will live like 15 years, something like this, 20 years. So they live a lot. So what happens that they're changing their physiology, like the metabolism, what happens that they can reproduce and suddenly they can live much more.
Mm-hmm.
This is one of the questions some people are trying to understand what is going on, if it's related to insulin and how they take care of like this metabolism resources. But it's something that we still don't know. I'm actually really curious to like to further studies to see what happens, because it's really interesting, like how can we control our aging related to how we use resources. So how does that change, and why does it change when they become reproductive? It's like natural selection to make sure that the colony is going to live longer, and what could ever possibly like start triggering that,
Yeah.
because this is already an exception, because usually workers do not reproduce. And yeah, we don't know. We a lot of new questions again to ask and to answer.
That's yeah. What's going on there? What's happening? So I'll go back. I'm gonna ask you a series, a couple questions. I'm gonna try to
Yeah.
get some numbers,
Okay.
and I'll kind of rely upon your expertise for Argentine and leaf cutting ants. So I want to get some numbers to kind of contextualize this. So, and you had mentioned specifically, what is the life expectancy of a colony, generally speaking?
Yeah. It also, again, it depends on the species. I think a nice example are the leafcutter ants, because they can live like 25 years old, because that's the age of the ant queen.
Okay.
Like I have worked with colonies that in nature, and when they go to the lab, they live less. But I have worked with colonies that were like 12, 15 years old, and this is like pretty old. Like,
Wow.
and but yeah, this is usually the lifetime of the colony, and it's related to the lifetime of the queen. But workers kind of live like 1 year, so they live much less than the queen. And this is again like one of the big questions: why do they live so much less? It's because like they're being eaten. I mean, they can be predated, and then they don't necessarily live a year. Naturally they live a year. So
Really? Yeah, it's not just like it's a dangerous job out there and we're seeing a high
no,
mortality rate. Like we have a capped life expectancy at
yeah,
12
it's
months.
biology. Yeah.
Yeah. So, okay, so we're kind of getting some life expectancy, you know, the of both the colony itself and some of the individual ants within that colony. How many ants are in the colony?
It also depends a lot on the species. Like a lot of the worms are made with colonies that have small sizes. So you can have a colony that has like 200 ants, and in some species, others that have a few thousand ants. Leafcutter ants, they have really big nests. Like in nature, they can reach 8 million ants in one colony.
Wow.
So they're huge. And in the lab, usually like you can have in my previous lab, we had a leaf current colony that had, at some point, that was Shakira. She had uh 150,000 individuals. That
Whoa.
was the colony that I used for my master, but I didn't use like the whole colony. So in my master, I used like 15,000 ants, something like this. That's why I had to work on machine learning to identify and count ants because they were a lot. It's impossible to count them when you're just have the human eye. You need some help of technology and computers to do so.
Yeah, thousands, if not millions of ants in some instances.
Yeah, it's just
Wow.
like a colony, you know. That's the thing. We have lots of colonies. So it's a lot of ants. There are some videos also on the internet that I think are pretty amazing that people did something similar to what I used to do as a kid. Like when I fill the ant nest with water, but they do that with cement. And after that, they excavate like the colony to see how is the structure underground, and it's insane. Like it's really big. They have all these little chambers connected, and it looks like you're going to a whole civilization, and it can go like 8 meters deep. It's really big going down, and it's insane. And they're very organized because some of these like pods, like these little chambers, they just have the fungi because leafcutter ants they are farmers, so they do not eat the leaves. They actually eat the the fungi that they cultivate bringing the leaves. So they give the leaves to the fungi grow, they eat the fungi. Like some of the ants, they also eat some of the liquids and the like the carbohydrates that are in the leaf, you know, like the liquids that are there. I forgot the word now, but they do that. So they're farmers, they take care of that, and they are so organized because they need to protect this fungi that they also have specific chambers for trash, so the waste. So they keep everything very separated so nothing gets contaminated. It's really amazing. Like it's a society incredibly organized. And instead very, and I think it's beautiful because they found they find organization in the middle of chaos, because a lot of things is happening at the same time. There's no central control, but this pattern is like the way that they cope with every single challenge. It works, and then life goes. It's pretty amazing.
That is amazing, especially that compartmentalization and how much of it is occurring, especially you're like, hey, it's 8 meters down. And also, little tidbit, had no idea that they weren't actually eating the leaves. They,
Yeah, they do not.
they're farming, they're getting that
They're
fungi, and
farmers.
so
Yeah.
they're kind of
And
what they go get. They cut these leaves, they bring them in, they may drink whatever moisture's on the leaf, and then they kind of just store it and wait for it to grow fungi, and then they
yeah,
just
yeah.
redistribute that in the colony itself
Yeah,
or the
the
hive
way
or
that
nest.
it works, like the brood, they cannot, like when they're like baby ants, they can only eat these fungi. So it's super important for the colony to keep growing. Like the new ants, they need that. And when they are older, then can, because they can cut leaves, they can actually feed on other substances. But this is super important. And I even have like this joke, like as I told you, like in my podcast I have an episode about ants, and my joke is because in Brazil leafcutter ants are considered like a major problem for agriculture. So every time that I say, oh, I study leafcutter ants, they're like, oh my god, did you finally find a way like to kill them all and take them all off the farm? And I'm like, nope, we're not gonna do that. And at the same time they're actually doing the same thing. They're also doing agriculture. Like they use organic matter to cultivate their food. And not only leafcutter ants do that, like agriculture has evolved in this Atini group. That's like the big group of ants that includes the leafcutter ants. And some of them, like in the past, they also cultivate fungi, and they do that by taking organic matter, but it's usually like dead organic matter. So they can take like a dead insect or like a seed, and they bring that and they do the same thing, like they're going to cultivate that to eat the fungi. But the thing about leafcutter ants is that they started getting like live matter, you know, like they went to a
Hmm.
tree that is there, it's alive, and they cut it, so it's kind of like very like energetic, powerful resource. And some people even ask the question like, are these colonies super huge? Because the ones that I told you that use uh, like organic matter that's not alive anymore, they're much smaller than leafcutter ants. These are like a few thousands, and the leafcutter is like millions. So what happens? Because they found this new way, they evolved to find this new way of very energetic resource, or is something else, like
Hmm.
are they I don't know, like did they started to getting really big nests, and then they needed extra something more energetic to find to keep growing. We don't know, people are still trying to figure that out, but I think it's also again pretty cool because how that happens, like evolution, I think it's something that is super interesting, like when we think about what exactly happened that may have triggered something, and also why does it work, and sometimes it's random, like it's
Hmm.
not something that has any specific function. Sometimes it evolved for a different function, and then it worked for other thing, and we sometimes it's very hard for us as biologists to find that information and understand what happened, to tell like the story, like this natural story of the organisms. Yeah.
Yeah, you have this distinction, right? You're like, hey, you know, we have these two separate ant groups. They're both cultivating fungi. One is relying upon, you know, dead uh, matter to kind of generate this fungi, and they have a smaller group. And then you have this other one that is basically going out and harvesting, matter that's probably, I would assume, more nutritious than dead matter, and bringing that in and cultivating that way, and that's exponentially increased the size of their nests. How did that come about, and what's the reason that that's working? And then you kind of have that, and you cross tabulate that with all these other different species and their kind of own niche way of doing things, and you get a super complex picture. And much as you're saying, it's kind of set around evolution.
Yeah, exactly that.
I want to go back to something you had said, because this is something we haven't really touched on. I know we talked kind of about the ant queen, and we talked about how some ants within a colony are able to reproduce, whereas some are not. What is and specifically, the fungi being really important for those broods, which I'm assuming are larvae or something to that degree. So can we kind of talk about how do ants reproduce and raise their young?
Yes, we can. I think I love talking about this because I think that's really interesting. Again, a lot of diversity that changes in a lot of species. Uh, my background is more on leafcutter ants, and I think it's the way they reproduce is the same for a lot of different ants, a lot of different species. But so what they do is something like this. Imagine you have a colony,
Hmm.
and this colony has a queen and has the workers, and at some point the queen starts like taking putting some new laying some eggs, and these eggs are going to be taken care by the nurses that are workers that do not reproduce. So they take care of them, they make sure they are not sick, they make sure that they're going to get food when they're pretty young, and they grow, and that keeps going. At some point the colony is going to reproduce, and how that happens, the queen start laying some eggs that can be reproductive. They can be females or males, and when they grow like and become like ants, they have wings. So this is one of the reasons that like ants are insects, and when we think, okay, what are things that all insects have? Wings and six legs, and sometimes people think, oh my, but ants, they don't have wings. They do in a specific time of their lives, they can
Okay.
have, and not all ants, the reproductive ones. So these males and females that can reproduce, they fly over, they fly away from the colony, and it's a little bit different, like they usually fly in different times, so they will not like reproduce with each other. So we have like the separation, like to maintain like diversity and genetic variation. And when the a female uh, ant leaves, I mean, she's gonna be a queen, like she's already a queen, but she hasn't reproduced yet. She flies over, and before she leaves, she usually eats a little bit of the fungi, and then she flies, like she looks for a new place to think, okay, this nice place can be in my new nest. And when she finds that place, she stops, and then she releases an alarm, like a pheromone that says, hello everyone, I'm ready to reproduce. It's like, and then after that smell is on the air, this pheromone, hundreds of males come to her, and they all like try to reproduce with her. In some species, I know that only one male can reproduce with the ant, and leafcutters can be hundreds. So after that finishes, all the males die. So whenever you see an ant, it's always a female. The males die after reproducing, and they just live for that. And after this the males die, this female, like, she takes off her wings with her with her legs, and she loses her wings. And after that, she starts like take yeah, it's a lot of things, like it's insane. And she defecates that fungi that she had eaten from the previous colony, and she starts taking care of the fungi. So she gets some leaves, then the fungi starts growing a little bit. And when the fungi is like at a minimal size that it's doable for her, she decides, okay, it's time to start reproducing. And then she stops, and she starts laying eggs. When the first eggs, like, they emerge, she takes care of them. And after that, they become ants. They're workers. They're not able to reproduce, and their task is to take care of the whole colony. So basically, she started a new colony, and this ant queen is gonna keep laying eggs until she dies. The whole day, that's what she does. And these new ants are gonna take care of all the other tasks of the colony. And the colony is gonna expand, expand, expand until someday it's big enough and it has resources enough, so it's able to reproduce. And then this ant queen starts the same new process. And one thing that you may think, when I tell you all this story, is that, oh my God, it must be really hard to, like, be alive and to reproduce in a colony, because it all relies on this single female that was trying to reproduce, to find a new place, to make sure that the fungi is not gonna die, that nothing eats her, that she doesn't get sick. So the thing is that when some of these colonies reproduce, they send like thousands of males, thousands of females, and usually like only a few are able to grow these colonies and finally reproduce again. So I remember one time that I was reading about these leafcutter ants, and I think there are some studies that estimate that they release like 10,000 females, and only 100 of these 10,000 is gonna become a reproductive nest. So it's hard, like it's hard. It's the struggle of life, A lot of them like are gonna start the process, but most of them die in this early phase, like making sure that I can start reproducing. And even if I can start reproducing, like nothing happens in the middle, like we're going to be able to maintain the colony.
It's a numbers game.
Yeah.
So that's really interesting. So the ants that are able to reproduce, they have their wings, and during certain times of the year, they just fly right off, and they just try to reproduce and start their own colony all on their own. And there's so many things that have to go right. They have to, first their personal safety. They have to make it to their destination. It has to be
Yeah.
a good destination. Then they have to have these male ants come and mate. Then they have to, basically defecate out and harvest additional fungi. And then it has to grow to a point that they can sustain like their own colony and then begin reproducing. There's a lot of things that
It's
have
a
to
lot
go
of
right.
things. Really hard. Like when I remember that I learned that, I was like, dude, life is hard. Uh, Once I was in a beach in Brazil with a friend of mine, and we saw this this time that the ants were trying to reproduce, so the beach was filled with males, like some of them already dying, and I saw lots of females too. And my friend was super excited, like, oh my god, the ants that you study. I'm like, yes, those are. And after that realized that on the beach, like the tide was gonna coming up, so they were all gonna die.
That's just
And
how it
like
is.
it's and
There
my friend was
goes.
like, you should do something. Like, what am I gonna do? Like, I can't. And also, like, they're probably gonna die even if I try to take them. It's a lot of them, like hundreds. And it was, yeah, it was insane. It's very hard. I was like, yeah, life's hard. You think we have it hard? Imagine being this ant. You know, her life is a struggle, girl. Like, she has to find a lot of things on her own. She has to deal with everything, and she's a single parent. Like, I used to joke, and she lives for brooding. She lives for, like, she's all the time laying eggs. She's all the time like giving birth. That's her life, you know, until she dies. Our life is easy compared to that, you know.
Yeah. And going back to kind of that whole process. So once that, ant queen successfully, uh, she makes it through the gauntlet, right? She's one of the elite few that that checks all the boxes, doesn't get washed away at the beach. Um, then she's just gonna kind of start her own nest and start laying, and then she in turn is gonna have lay eggs of uh, ants that are able to reproduce, both male and female, and they'll fly away, and that includes the males, right?
Yeah, the males also fly away. Yeah,
And they're just trying to kind of cross pollinate for biodiversity with these other ants of a similar species.
of the same species. Usually is always the same. Yeah, but different colonies. But yeah,
Wow.
it's insane. It's very hard. Very complex process. Process for sure.
Yeah, it is. That it is. And again, life is hard. Life is hard. Um,
Yeah, like I think like the hard life of the ant. Let's like, to me that's the title. When I try to explain her reproduction to every single person, they're like, how they do that? And I think it's very nice. Like, of course there are other ways, but I think this is the classic way that it happens. And it's different for other social insects, like on bees. Like, everyone think that ants are very similar to bees, but on bees, like, they changed the way that a specific bee eats, and then it becomes a new queen. So like we have like this reproduction that goes within the same colony, within the same beehive. But in ant nest is not like this. Like, they just spread, and it's pretty hard. It's funny to see how, and I think also interesting to see how these different strategies can work in different but yet similar organisms. So I think it's pretty cool too.
yeah, it is kind of what strategies other insects employ to increase the odds of, say, hey, we're going to live longer. Hey, we're going to have more biodiversity. That's really interesting.
Yeah.
Um, I want to know, what can people do to find out more about you and your podcast, and, about ants in general?
Yeah. I think there's a lot of resources about ants because they're pretty cool. But, so like on the internet, like YouTube has a bunch of stuff. There's this channel that's super famous that has like millions of subscribers that's called Ants Canada. And it's basically a guy taking care of his ants. And it's cool. I really like that. And also like the channel that I mentioned that has the World War Ant, they had a lot of videos about ants. It's very nice. There's a lot of documentaries, like Netflix I think has some. BBC has made like lots of them. And about me, I have a podcast. It's a podcast in Portuguese, and I also have a website that has some blog posts about themes related to science, my academic life, and what I'm doing, and then even some stuff about my some resources, that some episodes in my podcast. I'm in this process to do some things in English, but also keep them in Portuguese, because as like the whole intention was to achieve more Brazilians with scientific information, since we face such a hard time on negationism in this in our country. And so the name of the podcast is Charlando. So it's like the verb charlar from Spanish. That's like talking. And if you look like on this website, you can find a lot of resources, the podcast. And I have my Instagram account that it's always like open. I love talking to people about science over there. I always try to talk a little bit about science there. And also my Twitter account, and they're both are Mila underline Pamplona. So if you look for Mila Pamplona and science related, usually it's me.
Okay.
I don't have a very typical name. In Brazil, it's actually a nickname. So that's the good thing. It's easy. I'm easy to find. Yeah. But I think that's it. Like that's the best way to figure out some new things about things and what I'm doing.
And we'll make sure I'll have in the description of this episode for our listeners, all of the resources that you kind of mentioned, in addition to where they can find out more about you. So thank you very much for coming on and sharing all your knowledge and time today. It was really interesting to hear about everything.
Yeah, thank you so much for the invite. It was super cool. I love talking about ants. I love talking about science. So it was amazing. I love sharing everything with you. I hope I didn't make like big mistakes because I'm still kind of new in this area, but I think I try to keep it very general and very accessible. I think that's cool. Yeah.
You did an excellent job.
Thank you.
That wraps up our conversation with Mila Pamplona. We talked about the different tasks performed by different ant castes, how ants work together to collect food and resources, and the diversity of ant species. Go to the show notes for this episode to see the resources Mila mentioned during the episode. Do not forget to listen to Feeling Low by Times and Places on Apple Music or Spotify. And lastly, subscribe to the Simple Questions podcast to get notified when our latest episodes are released. Thank you for listening, and remember to keep asking questions.